You inherit a codebase with zero tests, and everyone says refactor it. But here's the trap. You can't refactor safely without tests, and you can't add tests without changing the code. It's a circular problem that keeps teams stuck. This walkthrough shows you exactly how to escape using characterization tests, seams, and golden masters. By the end, you'll know how to build that first safety net and break free from the catch-22. Most refactoring advice assumes you already have tests, but legacy methods are too tangled to test. They're doing 5 things at once, hitting the database directly, using statics everywhere. You'd need to refactor them just to make them testable. But refactoring without tests is exactly what we're trying to avoid. You're stuck in a loop where the solution requires the thing you're trying to achieve. Every modernization pattern, strangler fig, branch by abstraction, parallel run, feature flags, assumes you can verify that behavior hasn't changed. Without tests, you're flying blind. You can't safely swap implementations if you don't know what the old one does. You can't run systems in parallel if you can't compare outputs. Testing is the foundation everything else depends on, so we need to solve this problem first. Characterization tests capture what the code actually does, not what it should do. Think of them as scientific observation rather than quality control. The code might be buggy or completely insane. That doesn't matter yet. Your job is to document reality, warts and all. This flips traditional TDD on its head. Instead of describing ideal behavior, you're creating a snapshot of actual behavior. Once that snapshot's locked down, then you can start changing things with confidence. The process is simpler than you think. Pick a function, call it with some inputs, and watch what comes out. That 15 might be wrong. Maybe the discount calculation has been broken for years, but resist the urge to fix it. Your only job right now is to lock down that behavior. Write the assertion, make the test pass, move on. Think of it as putting the code in amber before you touch anything. The bugs will still be there to fix once you've built your safety net. Golden master testing takes characterization to the next level. The beautiful part: you don't need to understand what the code does. Generate hundreds of random inputs with a fixed seed so it's repeatable. Then capture everything the system outputs. That becomes your golden master. From that point on, any change that produces different output fails the test. It's brute force, but when you're staring at 10,000 lines of undocumented spaghetti, crude and effective beats elegant and impossible. We're using the approvals library here, which does the heavy lifting. Generate test orders with that fixed seed, run them through your legacy function, and the first time this runs, approvals creates a snapshot file. That's your golden master. Every subsequent run compares against that file. If anything changes, you get a diff. The genius is, you're not writing assertions about behavior you don't understand yet. You're just locking down what currently happens so you can refactor with confidence. Michael Feathers defines a seam as any place where you can change behavior without modifying the code at that location. Think of them as insertion points for testing. Object seams exploit interfaces or dependency injection to swap and test doubles. Link seams let you switch implementations through configuration. And if you're in C or C++, pre-processing seams with conditional compilation can be your escape hatch. Finding seams is like finding handholds on a cliff. They're your way up. The before version is a testing nightmare. Order processor directly instantiates its database connection, so every test hits real infrastructure. But when we inject the dependency through the constructor, we've created a seam. In production, pass in your real database. In tests, pass in a mock. Same code, 0 modifications at the call site. This one change unlocks everything. You can now write characterization tests, verify behavior, and refactor with confidence. When you're staring at a 200-line monster method that's impossible to test, don't try to test all of it. Extract your new logic into a separate, properly designed function. Test that new function in isolation with all the unit tests you want, then just call it from the legacy code. You're not making the mess worse. You're creating islands of tested, clean code that gradually chip away at the problem. It's incremental progress that actually sticks. When legacy code has hard dependencies you can't fake, database connections, file systems, make that dependency a protected method, then subclass it for testing. Production code stays untouched and keeps calling the real database. But in tests, you inherit from that class and override just getDatabaseConnection to return a mock. Suddenly, you can test query logic without spinning up PostgreSQL. It's not elegant, but it gets you tests today, not after a 6-month refactor. Capital One had critical COBOL banking code with zero test coverage. They didn't chase perfection. They used approval tests to lock in transaction behavior, then added characterization tests around the riskiest paths. They got to 60% coverage on what mattered most, and that was enough. That confidence let them safely refactor and gradually migrate to Java. Remember, you're not trying to hit 100% coverage. You're trying to get enough confidence to move forward without breaking production. For approval testing, approval tests works across multiple languages, and just snapshots are perfect if you're already in that ecosystem. When you need to isolate external dependencies, WireMock is excellent for mocking HTTP services. Pair it with test doubles for databases. Coverage tools like Jacoco or Istanbul show you where you're actually protected, but don't chase the metric. Use coverage to find gaps in your safety net, not to hit some arbitrary percentage. Focus on the scary parts first: code that handles money, user data, or critical business logic. Always write characterization tests before you touch anything. Document the bugs. Yes, even the bugs. You're capturing what the system does, not what it should do. Resist the urge to fix things while testing. That comes later. And whatever you do, don't attempt a big rewrite without tests protecting you. That's how projects die. Test and refactor. When you're dealing with complex business logic that makes you money, or when the domain knowledge locked in that code would be impossible to recreate. Rewrites aren't always wrong. Sometimes the technology is so dead or the code so tangled that starting fresh costs less. But here's the catch: you better have complete test coverage of existing behavior first. Otherwise, you're not rewriting, you're just gambling with production. This is where having tests really pays off. Want to gradually replace your legacy system? Tests verify the new code does what the old code did. Need to swap out a critical component? Your tests prove both implementations work the same. Running systems in parallel? That's just automated testing at scale. Even feature flags create exponential combinations that are impossible to verify manually. Every modernization strategy depends on tests as the foundation. You're not trapped in this catch-22. Characterization tests document what your code actually does right now, warts and all. Find seams where you can inject test doubles without rewriting everything. Sprout new functions you can test properly from day one. And when logic is too gnarly to understand, Golden Master testing captures outputs and protects them. Pick one messy function that causes the most pain and start there. Progress beats perfection. Pick that one function everyone's afraid to touch, the one causing production fires. Write characterization tests that lock down what it does today, bugs included. If output's complex, use Golden Master. Look for seams or create them using extract and override. When you add features, sprout fresh functions you can test from scratch. Don't obsess over coverage numbers. Track whether you feel confident deploying on Friday afternoon. That's your real metric. Start small, build your safety net one test at a time, then refactor fearlessly. Next up, the Strangler Fig pattern, where we replace entire legacy systems without a big bang rewrite.